Well, hello there, and welcome to my demonstration video on the soda can crush lab. This is my first year of ever trying this as a lab, where all of you guys are doing this and collecting data on it and analyzing it. So I'm hoping that we get some good data. The practice that I've tried works out pretty well so far, but we'll see how that translates to you guys working. First thing you're going to want to start with is fill up your ice bath. That's a term we'll be using a few times here in chemistry. It's just a way of removing energy from your reaction. So coffee can, actually this is red bean can, fill it up with ice. And the other thing you're going to want to do here is add some water. Okay, so it's a good idea to not fill this up completely with ice or with water, because you need enough room that when you dump your can in there that you're not going to make water overflow everywhere, and you also need enough kind of movement in the ice, so it's not just solid ice, that the can easily enough be submerged in there. So kind of get a nice balance of icy water that you can submerge stuff in there. Okay, so now we're going to grab our can, and one thing I want to caution you on with your can, make sure you've rinsed it out. So some of these have sugary stuff like Fresca in here, and the thing to be concerned about is that when you heat up sugar, it can caramelize. If you've ever made creme brulee, that's what you're doing, is you're heating up those sugar molecules so they actually bind together. It tastes kind of nice, it smells kind of nice, but if you caramelize it too much, you can burn it, and we will also make the whole school kind of smell like burning, or either nicely burnt sugar or badly burnt sugar. So try and avoid that by rinsing this out. So first thing you're going to do with the can now, after rinsing it out, is you're going to get 20 milliliters of water. I'm going to just really quickly guesstimate how much I've got here. You should do a better job of estimating this than I am doing right now. You can use pipettes to get a very precise measurement in there, and then you add that water to your can. So now I've got 20 milliliters of water in the can. You place it on your ring stand, which has the big ring and the wire mesh. You want to make sure that this is at a height that you can kind of adequately heat with the Bunsen burner. Right now, this is maybe a little bit high. I was actually practicing this earlier with my gigantic burner. That's why it's so high right now. Let's go ahead and start our burner, and then we can kind of adjust it to where we would like it. Okay. So, turn this on. Okay, so as you can see, this is just nowhere near close enough right now to be heating that very well. So what I'm going to do, I'm just slide this over. You want to be careful if you've been heating it recently, because the metal will be hot here. Remember, hot metal looks like cold metal. I'm going to lower it down to the flames within about maybe 6 inches or so of our can. And that'll be plenty right there. You're going to be doing at least 2 trials, maybe more if I can scrounge some more cans tonight. And you don't need to be actively taking the temperature of that throughout the whole lab. And it's actually not a bad idea to just kind of shoot for a temperature and remove the flame. So we take the flame off and measure how hot your reaction is, rather than kind of consistently keeping this in here. Really big caution here is don't just stick it in there and see what the number is. Oh God. Okay. Do a better job than, you should not be doing this one-handed like I'm doing this right now. Don't just stick it in there and look what the temperature is in there, because it takes a while to adjust. I don't know if you guys can see this right now. I'm gonna put this in front of the screen. You can see how as it's counting down there, it's kind of gradually going. It doesn't drop down right away. These thermometers take a while to adjust. So you want to make sure that that temperature reading is stable in your can before you actually record that. That was one mistake that I noticed a lot of people making in the reaction rates lab, is you were just sticking in there really quick, seeing what the temperature was, reading on here, and then calling that good. So give it time to adjust and kind of fully measure. So we're going to leave this on here for a while. Probably the biggest safety hazard here is making sure you don't do what I did. That you're talking and using one hand for multiple things. Work as a team, but don't knock over the can. Don't put your hand over the flame here. I'll give you probably 2 or 3 temperatures that I want you to test. And if I say to do 80 degrees, you don't have to test exactly 80. You can test 81.6 or 70, 77.9, whatever the actual temperature is that you record. Mostly what I'm looking for is just a range of different temperatures to see how this is effective. So, another thing to be wary of safety-wise, one thing we never do in chemistry is look over our reaction. That would involve me staring over the top of this. The reason for that is if anything kind of bursts up or explodes up, pops up when it boils, it could go right in your face. So if you are going to kind of take your temperature, just make sure that you're not sticking your face over that. So you might want to stabilize it with this while you do the temperature. I'm going to move this actually. I could probably get a little bit closer. I'm going to actually turn off our gas, see what this brings us to. It's still counting up 74, 77, 78, 79, 80, 81, 82, 82.6, 83, 83.5. It's getting pretty close to its final temperature. Right now it's at 84, 84.9, 80, okay, it's at 84.9, it's not going any higher. So I write that down. After I do this, you go ahead and grab this. Really quickly, you gotta invert it and dunk it in the ice water. So here we go. Okay, so notice this is what our can looks like now at this point. It has imploded. That means it's pushed in on this can. What you're going to want to do at this point is measure the volume. Go to the sink, fill this up the rest of the way until it's completely topped off, and then you will pour this into another graduated cylinder and see what that final volume is. So if you look at the label on here, you know that the original volume of this is 355 milliliters, and right now this looks like about 291 milliliters is what I would call that about. So you'd record that and then you'd try your next trial. See you tomorrow.